Hello developers. In this amazing video we will introduce JSON and look at some APIs that communicate in JSON. JSON stands for JavaScript Object Notation. It is a text-based format, meaning that it makes our life much easier when we are interchanging data between disparate systems that may store information differently, particularly integers and floating point data, because different CPUs may represent integers or floating point numbers differently. And if we store those values as text, it makes it much easier to exchange that information between those systems. JSON is based on sets of key value pairs, generally, and it's very easy to implement if you follow this graphical design provided on the home page of json.org. This is something you could actually do in a very short period of time because the spec is so simple. Here's an example of an API that communicates back to you in a JSON format, and I am going to open the second URL on this page. The URL submits a request to nps.gov, National Park Service, and is asking for information about a particular park. In this example, the park code is GRSM, and the information returned by the server is in JSON format, and my browser is happy to display that as more of a JSON-oriented display, and we can drill down using the browser tools into the different parts of that data that's returned. So as you're debugging the assignment that you will have in this module, it's a good idea to first look at the data returned by the server in your browser to see how it's being interpreted before you try to write code to parse that data. The raw data looks like this. Still not that hard to read, but it's not hierarchical, so if it was any longer than this, it might become problematic. But if you format it in what they call the JSON format, you can see that it is hierarchical and it's easy to follow. If you visit api.data.gov, as you're probably aware, online there are oodles of free APIs. This is just one of them. I use it as an example because it's well understood and fairly well supported, but I certainly encourage you to go look for others as well to build your skill set. The API key that is required to talk to this server is free, and I have applied for and received an API key that I'm using in the examples in this video. You are also encouraged to go ahead and apply for your own API key and interact with these servers as well. And as we did a few moments ago, we can build a URL to request information from the server, and then that simply returns information back to us. Again, on this slide, I'm showing you the JSON formatted or interpreted version of that request. I'm sorry, the response. Then at the bottom of the slide, I'm showing you what I guess could be considered HTML, but since it's returned as an expected JSON string, we'd probably safer calling it JSON than HTML. Notice that some of the characters are escaped. We use a backslash where necessary, but the JSON interpreter in the browser can handle that. It's no problem. In this slide, I have expanded on the data request to ask for information for 2 park codes from the National Park Services server. I'm asking for park code ACAD and park code GRSM. And let's click on that. I don't know why I'm getting this notice. I haven't received this before. It's rather interesting, but I'm going to continue on at my own risk. Oh, I think I know what I did. I think I need to... Actually, to be honest, I'm not sure what I did. So I am going to copy this URL rather than clicking on it and head back to my browser again and try this from the browser. And that worked a lot better. Since we asked for information from 2 different parks in the National Park System, we got 2 indexed values in the data section of this response. The first is the 0 index and has the information for the first park code, which is pretty extensive. And if I collapse that, I get the information for the second park code, which is also pretty extensive. So there's a lot of information here, and I find this an invaluable tool for browsing it before I start writing code to extract information from it. Let's move on now to look at some working code. I provided you with a donor project. You are encouraged to pull that down from GitHub or download it from the LMS and load it up into Visual Studio, and then we'll talk about it together. This project uses a third-party library from Newtonsoft, which is a very useful JSON parser and processor. You may have to install that in your Visual Studio environment, and it's not a problem. It's free. It's easily understood. So if that becomes an error when you try to run the project, if it doesn't build because it's missing this third-party library, then go ahead and fire up NuGet and install that. Three simple lines of code to get us started. This is part of the project. I just extracted it so we could focus on it. We create a web client object. We request information from the server using the same URL that we looked at in a previous slide. That is downloaded into the client object and then stored in a JSON string. And then Newtonsoft gets into the business. We simply parse the JSON string into what we call a J object or JSON object. And then we can navigate through that object based on the key value pairs that we saw when we browsed it in our browser. So let's do that now. I got a little bit ahead of myself here. This is another example. Let's go back to the project. And before we do anything else, we'll just run it to make sure that it works. If I click on the Smoky Mountains National Park alerts, that submits a request to the government server, and it's returned in a form of JSON, and I extracted part of that JSON and stored it in that text box. If I ask for information about that park, that's another API request, and I extracted some information from the response from the server. I extracted, for the most part, URLs to photos of the park just to show that I could. There's a lot more information in that response from the server, but I only extracted part of it. Let's look at the code then that does this work, and we'll see how easy and straightforward this can be. So to get there, I'm back in the design mode of the form again. I'm simply going to click on the button. That drops me into the code, which is the event handler for that button, and that event handler invokes a method, so I am nicely modularized here. And I don't know where that is, so I can right click on it and select go to definition, and that will take me to that method. And that method does what we saw on the slide a moment ago. It creates a web client. The web client submits a request to the API server, receives a string back, stores it in a variable called JSON string, and then for some debugging I simply wrote that to the console. I may look at that, I may not. And then I parse that using Newtonsoft classes. My JSON string, which was just a string of text, is now a JSON object which I can navigate. Knowing what I know about this JSON object, I saw that it had the value, or the key rather, data in it, because I saw it when I browsed through it with Firefox. I can do a get value on the word data, and that will extract the data part of that JSON response. And then knowing that the data part of the response had the word title in it, I can extract that. And as you can see, I can continue to drill down into the individual parts of that JSON response by name, because I know there's a thing called title in that response. And just to review, let's go back. Back in the browser again, I have pasted in the URL from that source code we were looking at, which is right here. And that helps me decode what will be coming to me in that JSON string. And in that string, I'm going to see that there is something called data. There is a data sub 0, so data is indexed. And then there is a title inside of that 0th index. Now in my code, I extract data, I extract the 0th index of data, and I can extract the title underneath that 0th index. And the title is going to be road closures due to weather conditions. And then what I do with that is just post it into a text box on the form. And this is simply an illustration of how I can drill down into the JSON data, knowing the key value pairs, and get out the information that I'm interested in. Another trick I can play is I can deserialize the entire string and convert it into a set of key value pairs, and then iterate over those key value pairs just for the fun of it. And again, I'm just writing to the console here simply to illustrate that I can do that. Now, the deserialize to dictionary is a recursive method that I wrote that simply steps through the key value pairs, and if one of the values in the key value pairs happens to be another dictionary, it iterates over that dictionary. So the order of things that are printed out here may not be the greatest, but it's an illustration of how we can access that JSON data. So let's set a breakpoint in this code And I'm going to put it in line 30. This is right after we've extracted the 0th element in the data and gone after that title value. And let's run that. Click on the first button, Smoky Mountain Alerts. The breakpoint stops us, and I'm going to hover over data token. And the data token, you can see, contains all the information in that 0th element. And there's the title. Road closures due to weather conditions. It's a key value pair. The title is key. The value is road closures due to weather conditions. The value can change. The key will not change. So I can always search for that key to get the corresponding value. And I'm going to stop that. Break out of that program. Now let's go back to the form design and let's look at the second example on this page. So double click on the second button, Smoky Mountains National Park Info. And that takes us to line 53, which calls another method, GSMNP info. Let's right click on that. Go to definition. Here's another method that demonstrates again how to drill down. And here I'm primarily interested in the phone numbers, if there are any. As I did before, I create a web client, I make a request to the API server. The API server sends me back some information. I parse it into a JSON object. I grab the data key from that object. Then I index into that key and get the 0th value of the data. Then I index into that 0th value and get the contacts key. And then in the contacts key, I drill down once more to get the phone numbers from that contact. So I'm drilling down into subsequent nested key value pairs to get what I need. And then once I get there, I know that that phone numbers token or that phone numbers key consists of multiple values, and I extract those one at a time and append those to that text box. So again, the way I view it is a series of drill downs. I could collapse this into one line of code if I wanted to, but I think it's more easily understood if first I get the data key, then I get the contacts key, then I get the phone numbers key, and then I drill down into the individual phone numbers and pop those into the text box. If there's only one phone number, it still works. If there's 10 phone numbers, it works just as well. The last thing I do in this method is start back from the data key again. So I kind of step back up in the hierarchy, go to the 0th element in the data key, and again, there's only one element, but it's still going to be the 0th element. And then I drill down into the images value, and I know the images value consists of a set, and I access each one of those individual set elements by using that enhanced for loop. So it's not that hard to do once you study an example and you have a good feel for how to navigate that data by looking at it in the browser. Okay, the next thing we'll do is move on to another example where we will create a class in a vacuum. We'll call the class fruit. And then we will serialize and deserialize that class. So instead of making an API request to a server, we're going to do our own little self-contained example using a class that we create. We're still using the Newtonsoft JSON classes here as well. If If you go back to the form design again and go to the second tab, in the second tab we're going to enter some information about a fruit and then click the Serialize button to create a JSON file in our project that serializes that instance of fruit. Before we do that, let's look at the fruit class. Over in the Project Explorer, the fruit class has a name property, a weight property, a date picked, a condition using an enum, and a quality. And then I've also provided a constructor that takes all of those properties and initializes them appropriately. An empty constructor, which is the default constructor that doesn't do anything except provide its own existence. And a toString, which is something I can use just to make sure that my program works. It creates a string representation of the current object using the properties of that object. So let's go back to our program and let's run it. Click the second tab for Serialize, and let's just put in some information to create a fruit object. If you double click on the date time picked, it will automatically populate that for you. It's just a headache to type it in. And you don't have to change the file name. SER is kind of a standard for serialized data, but JSON will probably be a better choice in this case. I'm going to leave it the way it is because it's just between us anyway. Click Serialize, and it wrote fruit.ser, which is a serialized version of this instance of the fruit class. And if I go to the File Explorer and take a look at the project that I'm browsing, that I've got open, I don't see fruit.ser in here. And where else might it be? Could it be in the bin folder? Could it be in the debug folder? And there it is. How did I know that? Well, I knew that because when I wrote the file, I took the default file path, which happens to be /bin/debug, which isn't the greatest, but if you know it's there, then you're fine. If we look at that with some text editor, I'm using Notepad++ that has some color in it, you can see that it looks just like that string that was returned to us by the API server in the first example. So it hasn't been parsed by a browser yet. The browser doesn't know that this is JSON because obviously we're not in a browser. But this little Notepad++ utility simply shows me the raw text that was written by the serializer. Okay, we haven't seen how this is done yet, but we have seen the results. So let's go back to our program and let's stop it if you haven't stopped it yet. And let's look at the code. Let's double click on the Serialize button. And here is a very simple and straightforward serialize. The first thing we do is create a fruit. So we use the constructor in the fruit class. We use the values from the text boxes on the form. I default the condition of the fruit to ripe, and I add a quality. But there's really not a lot to it. Once I've got a fruit object, I can call serialize, pass it the fruit object, pass it the name of the file I'd like to write to, and it does the work. Now where is Serialize? Serialize is a Newtonsoft thingy-do. Okay? So my serialize logic calls a couple of a couple of Newtonsoft classes, does a little bit of housekeeping on the file name, and I'm good to go. This is easily understood and easily cloned if you'd like to do it yourself. All we're doing here is creating a serializer object, deleting the file if it already exists, creating a stream writer object, creating a JSON writer object, so nothing specific at this point. We don't know anything about fruit at this point. And here in line 24 is where the good stuff happens. We're serializing our object and we're writing it through the JSON writer, which has a hold of that file that we opened, and we're done. Notice that this little chunk of code knows nothing about fruits. Okay? As long as your object is serializable, and that's a little bit beyond us right now, but our fruit object is serializable, then it works. So we can pass theoretically any serializable object to this method and it will do the job for us. Okay, go back to the form design again. Click on the Deserialize tab. On this tab we have a file name, which we're going to refer to the same file we created a few minutes ago. There's no reason to change that. And a Deserialize button. Well, how do you think that works? Double click on the Deserialize button. That takes us to the event handler. One line of code. One call to a Newtonsoft, I keep saying JSoft, Newtonsoft method, and we're good to go. So where is this thing? Right click on Deserialize, go to definition, whoops. There it is. One call to a Newtonsoft object wrapped around or buried inside my Deserialize method. So another layer of modularization. And all I have to do is call Deserialize object and it does the work for me. As an aside, this is probably the kind of code that you would want to wrap in a catch block. Because there are things that can go wrong here. The file name might not exist, the permissions might be wrong, the thing that we're trying to deserialize might be totally munged up and impossible to deserialize. And it's nice to do a little bit of error handling. Now, after I've done the error handling, I broke the method because it doesn't return something if it falls into the catch block. So what do I want to do? Let's put something here. Console.writeLine error deserializing colon space plus ex.getLocalizeMessage or whatever it is in C# message, not Java. And at least that gives me a fighting chance of debugging. Not a really good way to handle this error by any means, but it's a start. But I've still got this problem. The code will not compile because the deserialize method is advertised to return an object, but it's not returning an object if it falls into the catch block. So what I can do, there's a couple ways to handle this, is in the catch block, just return null. Null is an empty object, and that works. That makes the compiler happy, and that tells the world that if something goes wrong, I'm going to return a null object back. Is that the best way to handle this? I'm not sure it is. The original return in line 30 is fine if all goes well. It drops into that return statement, it deserializes, it sends back a reference to the new object, and you're all good. If an error takes place, it returns a null, and it's up to the calling method, whoever calls deserialize, to realize that a null value has been returned, and that's okay. We probably want to make that a little clearer. And in the documentation for this method, we'll say attempt to deserialize. And in the returns, we will say the deserialized object in the file or null on error. At the very least now, we've told the world that if something goes wrong, we're going to send you back a null. Another thing we could do is raise another error. Potentially, right here, we could throw an exception. And make a big stink right there. By doing that, we broke the method again because now we've got some code that cannot be reached. When it gets to line 40 and throws the exception, it will never get to line 41. That would require us to comment that out. Just another possibility for handling that error. And then we'd have to go up here and the deserialized object in the file or throws an exception on error. Another way to handle it, it's going to be up to you and your team to decide what the best way is. You may have a standard way that errors are handled, or you may want to just do the best that you can do. One more quick point to make here. Notice that this method is parameterized, meaning that I can call it with any reasonable, legitimate, proper data type as the parameter. So let's go back to the usage of that method. And you can see that when I call my deserialize method, I'm replacing the T with fruit. So it is a parameterized method, and I have to provide the name of a data type in there. That means, kind of underlying implication, that fruit is deserializable. And of course we know that it is because we've already shown that. But when we get to here, we're calling JSON convert.deserialize object, and that is also a parameterized method. And that T, again, is replaced by fruit. So the method that we're calling knows something about fruit, and what it knows is that fruit is deserializable. Okay, that brings us to the end of this presentation. I encourage you to study the code. I think that an interesting extension of this code would be to add another property or two to the fruit class and run the code as is and see if it serializes all of the properties in the fruit class, including the one that you added, and also make sure that it deserializes that property as well. And that'll be a very good introduction to using this code and basic serializing and JSerializing to and from JSON files. Thank you.